I've been working on a game project recently about managing your own art exhibit from paintings that you barter from people. One of the mechanics I want to add is for some of the paintings that come in to have a layer of old varnish on them that the player needs to clean off in order to restore their value. My first idea on this was to create a drawing system that would let the player remove the varnish layer directly from the texture of paintings. Drawing to a texture in Unity requires two different steps. Firstly, you need to get the coordinates on the texture that you want to change color. Then you need to set the pixels to change and update properly to reflect the new color on the texture. The first step is easy enough, as we can do a simple camera to mouse raycast. Rays in Unity will store the hit information of the texture as a texture coordinate, which is a coordinate represented on the object's UV map. Texture coords return a -0.5 to 0.5 vector2 value. This is based on how a standard texture UV maps onto a given object. We can then translate that into an exact pixel position by multiplying the texture coordinate by the width and height of the given texture. Now that we have our exact pixel coordinate, we can now modify that pixel plus some space around it to simulate a brush mechanic. In C# we have access to the setPixel function. This will let us change each individual pixel however we want, but in order to have them update properly on the texture, we need to call .apply. Apply is known to be a highly intensive function to call, and while we could afford to call it once per frame, moving at high speeds would result in our brush seemingly skipping along the page. In order to get around this, we are going to draw the pixels to the texture using a compute shader. Compute shaders can be quite scary at first glance, but for our needs today, we are going to keep it quite simple. We're going to have 5 open parameters, one for the texture we are modifying, one for the pixel position, one for the brush size, one for the resolution, and the last for our desired color. Compute shaders can be thought of as being one giant for loop. We are going to iterate through the coordinates of the texture until we are at the correct pixel position. We can use the built-in length function to then increase the size of the area around the pixel that we are changing the color of. Last, we then set the pixel equal to the set color and make sure we are calling this compute shader from our C# script. We can now draw to the texture. Now this still leaves us with the problem of our brush skipping at high speeds. To solve this, we are going to track the position of the pixels we are drawing to and get the distance and direction between each. Afterwards, we will run the compute shader again for a set number of pixels in between to simulate a full smooth line. Drawing to a texture means that so long as the UVs of a model are wrapped properly, this method will also allow for drawing 3D models. And we can even pair models together to the same texture. That's it for today's video. If you want to help support the channel, or if you want access to my source code and Unity setup, feel free to head over to my Patreon where I have my Unity scenes and scripts shown in this video available for download.